Since the dawn of humanity, people have looked up at the night sky and dreamed of reaching the moon. That dream finally became reality on July 20th, 1969, when Neil Armstrong descended the ladder of the lunar module Eagle and prepared to step onto another world. But this historic achievement was not sudden. It was the result of years of struggle, risk, and determination during the Cold War, when the United States and the Soviet Union raced to dominate space. Early American missions suffered repeated failures, equipment malfunctions, and tragic accidents. Many scientists believed landing on the moon was simply impossible. Still, NASA continued forward. Project Mercury proved humans could survive in space. Project Gemini developed essential skills such as maneuvering spacecraft, docking in orbit, and performing spacewalks. These missions built the foundation needed for Apollo. Then, tragedy struck. In 1967, astronauts Gus Grissom, Ed White, and Roger Chaffee lost their lives in the Apollo 1 cabin fire during a ground test. The disaster shocked the nation, but it also led NASA to redesign spacecraft systems and strengthen safety procedures. Progress resumed. Apollo 8 successfully orbited the moon. Apollo 9 tested the lunar module in Earth orbit. Apollo 10 performed a complete dress rehearsal near the lunar surface. Finally, Apollo 11 launched on July 16, 1969. Astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins began their three-day journey toward history. As Eagle separated and descended, computer alarms sounded and fuel levels dropped dangerously low. With only seconds remaining, Armstrong manually guided the spacecraft to safety. "Houston, Tranquility Base here. The Eagle has landed." Hours later, Armstrong stepped onto the moon, speaking words heard around the world. "That's one small step for man, one giant leap for mankind." Humanity had finally reached another world. For more than 2 hours, Armstrong and Buzz Aldrin explored the lunar surface while Michael Collins orbited above in the command module. They planted a flag, deployed scientific experiments, and collected samples of lunar soil and rock. Their footprints remain untouched on the moon even today. Apollo 11 proved the journey was possible, but exploration was only beginning. Apollo 12 followed, demonstrating remarkable landing precision, despite lightning striking the rocket shortly after launch. The crew successfully expanded scientific research on the lunar surface, proving NASA's growing confidence and technical capability. Later missions pushed exploration even further. Apollo 15, 16, and 17 introduced the Lunar Roving Vehicle, allowing astronauts to travel across vast distances on the moon. For the first time, crews explored mountains, valleys, and ancient impact craters, collecting samples that revealed new insights into the moon's volcanic past and the formation of the solar system. Apollo 16 faced technical concerns before landing, nearly forcing the mission to abort. Yet the crew successfully landed and explored the lunar highlands, returning with valuable geological samples. Each mission increased knowledge and confidence, but public interest slowly began to fade. Political priorities shifted, and budgets tightened. Planned future missions were canceled. Still, one final journey remained. Apollo 17, launched in December 1972, would become humanity's last visit to the moon. Astronaut Eugene Cernan, geologist Harrison Schmitt, and command module pilot Ron Evans carried out the most extensive lunar exploration ever attempted. No one knew at the time how long it would be before humans would return. Apollo 17 achieved record-breaking exploration. Over 3 days, Cernan and Schmitt spent more time on the lunar surface than any previous crew. Using the rover, they traveled farther than any mission before them, deployed advanced scientific instruments, and collected over 100 kilograms of lunar samples. One of their most important discoveries came when Schmitt noticed unusual orange-colored soil, evidence of ancient volcanic activity. The finding reshaped scientific understanding of the moon's history and remains significant even today. Before leaving, Cernan fulfilled a promise to his daughter by writing her initials in the lunar dust, knowing they could remain there for millions of years. Then, preparing to depart, he spoke the final words ever delivered from the lunar surface. "We leave as we came, and God willing, as we shall return, with peace and hope for all mankind." Apollo 17 splashed down safely in the Pacific Ocean, marking the end of the Apollo era. Since then, no human has traveled as far from Earth. Yet Apollo changed humanity forever. It advanced science and technology and gave people a new perspective on Earth itself. Images like the famous blue marble showed our planet as fragile and united, floating alone in space. The moon was never meant to be the final destination. It was only the first step. Today, new missions once again look toward the moon, Mars, and beyond. The spirit of exploration that powered Apollo still inspires future generations. Because space is still there, and someday, humanity will return. Although Apollo 17 marked the end of lunar missions, the story of human space exploration did not end there. The lessons learned from Apollo directly shaped the next phase of space travel. NASA shifted focus toward building reusable spacecraft and long-term orbital missions, paving the way for the Space Shuttle program. In 1981, the first Space Shuttle mission launched, carrying astronauts back into orbit aboard a reusable spacecraft designed to reduce costs and expand access to space. Over 3 decades, shuttles deployed satellites, conducted scientific experiments, and helped construct the International Space Station. The International Space Station, or ISS, became humanity's permanent home in orbit. Built through cooperation between multiple nations, astronauts from around the world have lived and worked aboard the station since the year 2000, conducting research in microgravity that benefits medicine, engineering, and Earth science. Meanwhile, robotic missions pushed deeper into the solar system. Spacecraft visited every major planet, revealing extraordinary discoveries: volcanoes on Jupiter's moon Io, oceans beneath icy surfaces, and evidence that Mars once had flowing water. Mars, in particular, became a new focus. Rovers such as Spirit, Opportunity, Curiosity, and Perseverance explored the Martian surface, searching for signs that life may once have existed there. Each mission expanded humanity's understanding of our neighboring planet. At the same time, private companies began entering spaceflight, lowering launch costs and opening new possibilities for exploration. Reusable rockets, once considered impossible, began landing and flying again. Half a century after Apollo, humanity once again prepares to return to the moon, this time not just to visit, but to stay. The next chapter of exploration is already beginning. Today, space agencies and private companies are working together to establish a sustainable human presence beyond Earth. NASA's Artemis program aims to return astronauts to the moon, including the first woman and the next man to walk on its surface. Unlike Apollo, Artemis plans to build long-term infrastructure. A small space station called Gateway will orbit the moon, acting as a staging point for future missions. New lunar landers and advanced spacesuits are being developed for longer stays on the surface. The moon is now seen not only as a destination, but as a testing ground for missions to Mars. Its resources, including water ice discovered near the poles, could one day supply fuel and life support systems for deep space missions. Mars remains the ultimate goal. A human mission to Mars would be far more complex than Apollo. Astronauts would travel for months, live on another planet, and return after years away from Earth. But engineers and scientists are already developing technologies needed to make this journey possible. At the same time, telescopes in space now look deeper into the universe than ever before. Observatories such as the Hubble and James Webb Space Telescopes reveal galaxies formed billions of years ago and help scientists search for planets orbiting distant stars. Every discovery reminds us that our solar system is only a tiny part of a vast universe filled with possibilities. The spirit that powered Apollo continues, pushing humanity outward, step by step, toward new horizons. More than 50 years after the first moon landing, Apollo still stands as one of humanity's greatest achievements. It demonstrated what could be accomplished when nations commit to a bold goal and work together towards something larger than themselves. The Apollo astronauts often said their greatest discovery was not the moon, but Earth. Seen from space, national borders disappear. Our planet appears small, fragile, and precious against the darkness of space. This perspective changed how people viewed the world and inspired movements focused on protecting our planet and cooperating across nations. Future explorers will face new challenges. Missions to Mars and beyond will require innovations in propulsion, life support, and human endurance. Astronauts will need to live far from Earth for long periods, relying on technology and teamwork to survive. Yet history shows that challenges drive progress. Each generation builds upon the achievements of those before them. The footprints left on the moon remind us that exploration is part of human nature. From crossing oceans to climbing mountains and reaching space, humanity has always pushed beyond known boundaries. The moon was only the beginning. One day, humans will again walk on the lunar surface. Later, they may step onto Mars. And someday, explorers may travel even farther into the solar system and beyond. Because the desire to explore has never left us. And as long as we continue looking up at the night sky, humanity's journey into space will continue. As humanity prepares for its next great leap, attention is once again turning toward building a sustainable future in space. Scientists and engineers now study how humans can live and work beyond Earth for long periods, developing habitats, life support systems, and new methods to produce food and resources in hostile environments. Living on the moon or Mars will demand innovation. Astronauts will need protection from radiation, extreme temperatures, and isolation. Water and oxygen may need to be extracted from local materials, while advanced recycling systems will ensure nothing is wasted. Robotic missions are already scouting future landing sites, mapping resources, and testing technologies that will support human explorers. These machines act as pioneers, preparing the way for people to follow. At the same time, advances in artificial intelligence and robotics allow spacecraft to travel farther and operate longer without human control. Missions now explore asteroids, comets, and distant moons, seeking clues about how our solar system formed. Some scientists even study how future missions might capture resources from asteroids, providing materials for construction and fuel in space. Such developments could reduce the need to launch everything from Earth, making exploration more sustainable. Beyond practical goals, space exploration continues to inspire people across the globe. Children who watch rocket launches today may become the engineers, scientists, and astronauts of tomorrow. Every launch reminds us that exploration is not only about technology, but about curiosity, the desire to understand where we came from and where we are going. And with each new mission, humanity moves one step closer to becoming a true spacefaring civilization.